Hello dear student, welcome to our fourth lesson, and this is ion formation. Today we are going to look at ion, which is a positively or negatively charged particles. When an atom has a maximum number of electrons in its outermost energy level or the shell, it is said to be stable. That is, the maximum number may be 2 and 8. So when it is having the maximum number of electrons in the outermost energy level, then it is referred as stable. On the other hand, when an atom has no maximum number of electrons in its outermost energy level, then that atom is said to be unstable. All stable atoms are in group 8 of the periodic table. All other elements are unstable. And all unstable atoms or isotopes try to be stable through chemical reaction. So they either gain or lose electrons to gain the stable structure of the group 8 elements. A chemical reaction involves gaining or losing outer electrons, or maybe transfer of the electrons. The electrons in the outermost energy level are called valence electrons. Should not be confused with the valency. So this is valence electrons. When electron transfer takes place, an ion is always formed. Now let's look what is an ion. An ion is formed when an unstable atom gain or donate electron in its outermost energy level in order to be stable. Those which are gaining are usually non-metals, and those which are donating are usually the metals. Whether an atom gain or donate electrons depend on the relative energy required to donate or gain extra electrons. Formation of magnesium ion, so Mg2+, it's good to note that. The idea used to explain the formation of magnesium ion can be used to predict the formation of ions of other elements. Now let's see how magnesium has an atomic number of 12. So it has 12 protons, therefore it also have 12 electrons, and that is why we have atomic number 12. The electron arrangement will be 2 in the first energy level, 8 in the second energy level, and 2 in the last energy level or the third level, meaning it has 3 periods. It is in group 2. The magnesium atom can acquire stable electrons configuration of 2,8 by 1 losing 2 electrons to the outermost energy level, or gaining 6 into the outermost energy level. It is easier to lose 2 instead of gaining 6. So magnesium ion is therefore formed by losing the 2 electrons as shown below. We have magnesium atom here, or the element, which has 12 electrons in the energy level. The first one will have 2, then 8 in this energy level, and then we have 2 in the outermost energy level. So this magnesium will react by losing 2 electrons which are in the outermost energy level to get this structure. So this one will be less with 2 electrons. But remember, the protons here in the nucleus are 12, and the protons here are also 12. So protons do not take part in any chemical reaction. So what take part are the electrons. Therefore, it is good to understand when it is an atom, protons are 12 and they are positively charged, and electrons are 12 which are negatively charged, and then the resultant charge will be 0. When it loses 2 electrons, protons remains 12 with a positive, but now here you find a reduction of electrons by 2, so you'll have -10. When you add the 2, you'll get positive 2. So this positive 2 is now indicated here outside this bracket, and that is why magnesium form cations, which are positively charged particles. Ion formation for oxygen. Oxygen is a non-metal. It has an atomic number of 8. The electron arrangement is 2 6. So when you add 2 to 6, you'll get 8, meaning it has 8 protons, then it has 8 electrons. That is why atomic number is 8. The oxygen atom can acquire stable electron configuration of 2 8 by gaining 2 electrons to the outermost energy level. The ion formed is called an oxygen ion, written as O2 negative, as shown below. So we have that is a nucleus with 8 protons. Then we have the first energy level, then we have the second, and we have the first energy level carrying 2 electrons, and then the outermost or the second energy level carries 6 electrons. 1 2 3 4 5 6. So this makes a total of 8, as we have seen on the atomic number. Then after you have done that, you'll find that the number of protons are 8, electrons 8, and the charge is 0. When this one reacts, it will react by gaining 2 electrons. So after gaining 2 electrons, protons do not take part in the reaction, so they will remain as 8. And remember, protons are positively charged. Electrons will be more by 2. That is why you'll find that there is an increase in the number of the negative. So this one will be negative 10. When you add the 2, you'll get negative 2. So how do you write now the ion of oxygen? It will be this way. So this one was initial, then it will gain another 2 to get 10 in the outermost energy level, meaning this one is stable. Then you put the brackets and you indicate 2 minus. This is the charge. Valences of elements. So element, we have hydrogen, we have number of protons, then we have number of electrons. Electronic configuration is 1. It can either gain or lose an electron. So when it gains, it behaves like a non-metal, and when it loses 1, it behaves like a metal. Therefore, it can either be placed in group 1 because it can lose 1 electron like the other metals, or can be placed in group 7 because it can gain 1 electron to be stable like the other non-metals, especially the halogen group. Helium has 2 protons, 2 electrons, electronic configuration 2. It is stable, does not require anything. Lithium 3, electronic configuration 2 1, can lose 1 electron, therefore the valency is 1. Then beryllium is number 4, meaning the atomic number is 4, and therefore the number of protons 4. Then electronic configuration 2 2, lose 2 electrons, so to gain that structure, therefore beryllium has a valency of 2. Then we move to boron. We have 5 2 3 is electronic configuration or arrangement, loses 3 electrons, therefore it has a valency of 3. Then carbon is number 6. 2 4 is the electronic configuration, so you can gain 4 or lose 4, so the valency is 4. Now after we have moved to 7, you'll find that the electronic configuration is 2 5. So for this one, it cannot lose 5. It is difficult to lose 5. In this case, it can only gain 3 electrons to be stable. Therefore, the valency of nitrogen is 3. Then oxygen, valency 2 because it can gain 2 electrons. Fluorine has a valency of 1 because it can gain 1 electron. Neon is stable. It has an electronic configuration of 2,8, therefore does not require any electron or gain to be stable. It is already stable. Sodium has an electronic configuration of 2,8,1, so it can lose 1 electron to be stable, so the valency is 1. Magnesium has a valency of 2 because it can lose 2 electrons to be stable. We move to valencies of elements. Name of metals. You are provided with zinc 2. When you're told zinc 2, which the symbol is Zn, the valency is 2. So the number here in Roman is a valency of this element. Iron 2 will be valency 2. Iron 3 will be 3. Lead 2 to read 4 in Roman to be valency 4. Copper 1, copper 2, copper, barium 2, sulfur 4, and sulfur 6. So the Roman numbers here indicate the valency. The Roman numbers within the bracket represent the valency of that element. Radicals and their valencies. They are a group of atoms with a net charge that exist and react as a unit during chemical reaction. So the radicals react as a unit. Therefore, they will be treated like an element. The valency of a radical is the same as the value of its charge. Example, sulfate with a charge of 2 negative has a valency of 2, while ammonium with 1 plus has a valency of 1. Valency of radicals. We have ammonium. It has a charge of plus 1, so the valency is 1. Hydroxide 1. Nitrate we have 1. Hydrogen carbonate 1. Hydrogen sulfate 1. Carbonate we have 2. Sulfate we have 2. Sulfite 2. And phosphate we have a valency of 3. So when these one are combining with other elements, this is the valency or the combining power that will be used. So they usually interchange, as we are going to see later. So practice to remember all the radical valencies. And here is the assignment for you. Make sure you get everything right and refer the notes in case you have any challenge, but try to test your brain. Thank you.